Hi, you guys. Well, today we are starting the very most important module that you will do in Math 7. We are going to begin to learn to solve equations. And so for Math 7, you need to be able to solve a one-step equation, a two-step equation. You need to be able to do multi-steps on the same side of the equal sign, and then you also need to be able to solve inequalities. Okay, so in order to do this, you're going to need all those skills that you just tested on last week. So you're going to need to be able to combine like terms, you're going to need to be able to distribute, you're going to need to be able to distribute and combine like terms. And so if you haven't passed your test on those skills, please make sure that you come in during your Monday makeup for den time or stay after school. Besides staying with me, there's also the option of staying with the tutor every day in the library. Okay, so with that said, let's go ahead and get started. We're going to start with a class activity, constructing and deconstructing equations. Activity 1 says, transforming an equation, what are the legal moves? Okay, and then it starts with saying, consider the equation 12 equals 12. Is this a true statement? Okay, is it true? Does 12 equal 12? Hopefully all of you are sitting there thinking to yourself, yes, that is absolutely true. 12 does equal 12. Okay, so now with using this, we're going to go through and do this activity. For B, it says apply each operation to the equation 12 equals 12. Okay, so when you're given an equation, you are being told that the left side equals the right side. Okay, and then we need to say whether the resulting equation is still true. The first one has been done for you. So starting equation 12 equals 12. If we add 4 to both sides, we can see that the resulting equation is 16 equals 16, and that is still true. Okay, let's do the next one. If we have 12 equals 12 and we add 8 to both sides, that's going to give us a 20 equals 20. And we would say, yes, that is true. 20 does equal 20. Okay, let's look at the next one. It says add 4 to the left side of the equation only. So if I do 12 plus 4 and I only add the 4 to the left side of the equation, is the resulting equation true? Well, that would give us 16 equals 12. And so we would say no, 16 does not equal 12. Okay, let's look at the next one. 12 equals 12. If we multiply both sides of the equation by 3, so if we have 12 equals 12 and we times this side by 3, and we also times this side by 3, that's going to give us 36 equals 36, and that is a true statement. Okay, the next one. Take the 12 equal 12, divide both sides of the equation by 3. Yes, that is going to be true. 4 does equal 4. Okay, on the next one, it says take the 12 equals 12, multiply the left side of the equation by 3, and add 3 to the right side of the equation. I'm actually going to write this over here because I just need a little bit more space. Okay, so multiply the left side of the equation by 3 and add 3 to the right side of the equation. That's going to give us 36 equals 15, and we would say no, that is not true. Okay, the next one, multiply both sides of the equation by a half. So 12 equals 12. If I multiply this side by 1/2 and I also multiply this side by 1/2, I'm going to get 6 equals 6. And yeah, that's true. Okay, the next one, take the 12 equals 12, multiply the left side of the equation by 1/2. Okay, and multiply the right side of the equation by 2. So that's going to give me 6 equals 24, and we would say no, that is not true. Okay, now as we look back through this activity, what I want you to notice is anytime we were doing the same exact thing to both sides of the equation, it kept the equation true. Okay? Anytime we were doing different things to the left side than we were to the right side, the equation did not stay true. Okay, so for activity 2, it says start with the given equation, apply the action to construct an equivalent equation. Okay, so this right here, x equals 5, this is our original equation. And now we need to add 3 to both sides of the equation. Okay, so what that's going to look like for the transformed equation is x plus 3 equals 5 plus 3. Okay, and then you guys know that we can actually combine 5 and 3, and we can make that an 8. Okay, so this is the transformed equation. Okay, let's look at the next one. X equals 10. So if we take x equals 10 and we subtract 8 from both sides of the equation, what that's going to look like is this. X minus 8 equals 10 minus 8. And then you guys know that is going to become x minus 8 equals 2. Okay, that is going to be the transformed equation. Okay, let's look at the next one. X equals 4. Multiply both sides of the equation by 5. So if I take the equation x equals 4 and I multiply this side by 5 and I multiply this side by 5, 5 times x is going to get written as 5x equal to 4 times 5, which is 20. Okay. Next one, x equals 12. Divide both sides of the equation by 4. So I'm going to have x divided by 4 equals 12 divided by 4. So that's going to be x divided by 4 equals 3. Okay, now let's go to activity 3. Activity 3 says the equations below are equations you built in the previous activity. State the action you need to perform to deconstruct the equation. In other words, how can you get the equation back to what it was at the start of activity 2 to determine the value of x? Okay, so what we want to do is we want to take this equation and we want to be able to get it back to the original equation. Okay, so in order to do that, we're going to have to take the x plus 3, and if we want it to be back to just being an x, that means we're going to have to subtract 3 from both sides so that we're left with x equals 5 for the original equation. Okay, so the action was to subtract 3. Okay, let's look at the next one. I'm going to clear off some space here a little bit. Okay, so x minus 8 equals 2. Okay, so if we take the x minus 8 equals 2, if we want to get back to where it was just an x on the left side, we're going to have to do the opposite of subtracting 8, which is to add 8. Okay, so x equals 10. And we got to that by adding 8 to both sides. Okay, let's look at the next one. It says 5 times x equals 20. Well, if we want that to just be an x, right now it's 5 times x equals 20. If we want this to just be an x, we have to get rid of the multiplication of 5. So we're going to have to divide by 5 on both sides. That's how we end up getting x equals 4. Okay, and then the last one, when you have x divided by 4 equals 3, if you want to get back to where this is just an x, you're going to have to get rid of the divided by 4. And the way you get rid of a divided by 4 is by timesing by 4. And you have to do that on both sides. So x equals 12, and we got to that by multiplying by 4. Now, as you look at these two activities, one thing I want you to notice is in order to get rid of an addition, we had to use subtraction. In order to get rid of a subtraction, we had to use addition. That's because addition and subtraction are inverse operations. So they are operations that will undo each other. Okay? If we had a multiplication, the way that we got rid of that was by using division. And if we had a division, the way that we got rid of that was by using multiplication. And that's because multiplication and division are inverse operations. Okay, so this is really important. Addition and subtraction, those are inverse operations. Those operations will undo each other. So if you have a subtraction, you want to undo it, you use addition. If you have an addition, you want to undo it, you use subtraction. And then also multiplication and division. Those are inverse operations. So if you have a multiplication and you want to undo it, you use division. And if you have division and you want to undo it, you use multiplication. Okay, so now for the next part of the activity, or the homework, it says, determine whether the following actions are legal moves when transforming an equation. Write Y for yes or N for no. For the moves that are legal moves, name the property of equality. The first two have been done for you. Okay, now the thing that makes it a legal move is if you do an operation and you do it to both sides of the equation and the equation stays equal, that is called a legal move. Okay, so let's go back to this activity here. All of the ones in yellow, those would be considered legal moves, okay, because we're doing the exact same thing to both sides of the equation and the equation stays equal. Okay, so those are legal moves. The ones in pink, those are not legal moves. Okay, when you have an equation, you can't do different things to both sides and keep the equation equal. So with that in mind, let's look at these. Number one's been done for us. Add 5 to both sides of the equation. Yes, that is a legal move. The property of equality that says that we can do that is the addition property of equality. Okay, the addition property of equality says that if you add the same thing to both sides of the equation, it keeps the equation equal. Okay, number 2. Add 5 to the left side of the equation and subtract 5 from the left side of the equation. Okay, so let's go ahead and look at the next one. It says add 5 to the left side of the equation and subtract 5 from the left side of the equation. That is not a legal move. In order for it to be a legal move, you have to do the exact same thing to both sides of the equation. Okay, so if it's not a legal move, you're not going to have anything in this box. Okay, number 3, multiply one side of the equation by 7. No, not a legal move. You can't just multiply one side of the equation by something. In order to be a legal move, you have to multiply both sides by that same thing. Okay, the next one, subtract 8 from both sides of the equation. And we would say yes. And that is called the subtraction property of equality. Okay, so as long as you subtract the same thing from both sides of the equation, it stays equal. Okay, number 5, multiply one side of the equation by 10 and divide the other side of the equation by 10. No, even though we're talking about a 10 on each side, on this side you're multiplying and on this side you're dividing, and that is not a legal move. Okay, number 6, divide both sides of the equation by 4. We would say yes, that works. And that is the division property of equality. The division property of equality says as long as you divide both sides of the equation by the same thing, it keeps the equation equal. Okay, the next one. This one's a little bit tricky. divide the right side of the equation by 1/3 and multiply the left side of the equation by 3. Okay, let's just look at this. Okay, if we divide the right side of the equation by 1/3, remember when you divide fractions, you actually flip the second one and multiply. So that's going to be 27. And then if we multiply the left side of the equation by 3, that is going to be 27. 27 does equal 27, so that is a legal move. Dividing by 1/3 is the same thing as multiplying by 3. Okay, let's look at the next one. Just divide one side of the equation by 0.01. So let's just say our equation is 10 equals 10. Okay, you guys know that 0.01 as a fraction, this is tenths, this is hundredths, so this would be 1/100th. So if we divide one side of the equation by 1/100th and we multiply the other side of the equation by 100, that actually is a legal move, because when we divide by 1/100th, that's going to be times by 100/1. Okay, and then the next one, if we multiply one side of the equation by 10 and we multiply the other side of the equation by 5 and then 2. Okay, so let's just go ahead and let's say our equation is 3 equals 3. Let's say we multiply one side of the equation by 10 and we multiply the other side of the equation by 5 and then by 2. We could say, yeah, that is a legal move. Okay, because this would really be a 10. So we're really multiplying both sides of the equation by 10. Okay,